All right, lesson 7-9. Kind of a gross fact of the day today. Okay, here is your math box from yesterday. And your study link. And today's lesson. Page 334, comparing rates in a triathlon. Okay. The triathlon consists of 3 stages, or legs they call them: swimming, biking, and running. The average participant takes 12 hours and 35 minutes to complete the race. If the average participant travels all 3 legs of the race at a constant speed, how many minutes does it take to travel 1 mile? So go ahead and figure that out. You should be able to use a proportion on this one. Pause the video. I started to set up my proportion there, minutes and miles. So 1 mile, we don't know how many minutes. So how many miles are they going? Need to figure that out. And how many minutes did that take? 12 hours. Figure that out. 12 hours and 35 minutes. Okay, for the minutes, 755, because you take 12 times 60 minutes in an hour is 720 plus the 35 minutes, so 755. Add up all your miles and you get 140.6. 755 divided by 140.6 is about 5.4. Whoops, it's about 5.3698. So the answer book says 5.4, so right in that area. Okay, the following statistics reflect the average times for completing each leg. So the average rate and then the equation. So the swimming, and the biking, and the running. Go ahead and pause and work those out if you can. So approximately 32 minutes for the swimming, and then they showed their work there. 76 minutes for the swimming because it's an hour and 16 minutes. So that's 76 minutes divided by, look up at the top, swimming was 2.4 miles. So 31.666, okay, 32 miles. So they showed you what they did there. Okay, so if for swimming, they went 32 per minute, that's how far in half of a minute? 16. A minute and a half, we'll add the minute and the half minute together, you get 48. 5 minutes, I would take the 1 times 5, so take 32 times 5, 160. Now you have to figure this backwards. Well, this one's not too bad. How does 160 turn into 320? You double it, so let's double the 5 and get the 10. 96, well, the way I'm looking at it is 2 48s make 96, so 2 1.5s make 3, and that's how you complete those tables. So the biking and the running, answers are right there. And then down below, they just ask you how you figured those out. Explain how you know. I think I have that on the next page here. No. It's down below. Let's just put this one up there then. Slide down. Explain how you know. How they make sense. Well, make sure that they make sense by looking at the previous numbers, right? Okay, let's go on to the next page. Okay, using these values from problem 3, and we will graph them. So it says to use a different colored pencil for swimming and the biking and the running, and then that might be the easiest, or a highlighter, or if you don't have one on you, just mark them. It's no big deal, they're the same color. So pause the video and do that. And there's how your graph should turn out, looking like that. Then answer questions 6, 7, and 8 here. If you only had the graph to use, how could you tell which leg was the fastest? Why can't the points on the graph for each rate be connected to make a straight line? And explain how you know which variable is independent and which one's dependent. Okay, so if you don't know the answer to number 8, we haven't talked about independent and dependent very much, so I'll try to explain that, but go ahead and pause now and try to work on those. Okay, so for number 6, the line that goes up the fastest, the steepest line, the one that's more straight up and down, more vertical, that's the fastest. Number 7, why can the points on the graph for each rate be connected to make a straight line? For every participant, you know, it's constant. Basically, I would have just wrote it's constant. The ratio stays the same for each one of them separately. And then number 8, the time is independent because the distance that you travel depends on the length of the time. So the time is independent. Depends on how long you're biking, you know, for how far you go, you might say. Okay, the new house is being constructed with a rectangular prism for its base and a triangular prism for its roof. The outside of the house, including the triangular ends of the house, the roof, will be made of wood. How many square feet of wood should the builder purchase for the 4 walls and the ends of the roof? Okay, so basically they want to know the surface area. And since it is a house, don't forget that whatever the house is sitting on, the dirt, the ground, the cement, okay, the concrete, you don't have to figure that part out. So it's the 4 sides of the building, the 2 rectangles for the roof, and the 2 triangles for the roof. So pause and figure out that surface area. Okay, I will try to write using my finger here. Okay, so this side is 40 by 15. So if I'm figuring out this side and then the back here, okay, we have 40 times 15 is 600 times 2, because there's 2 of those sides. We have 1,200 square feet on those 2 sides. The front and the back, we have 30 times 15. And then we have 2 of those. Each one is 450, so we have 900. So we have the bottom part of the house done. Now we need to figure out the roof. So we have, let me see if I can change colors here. Okay, we have 40. And what is this part here? That part, back up here. We don't have to do the roof. We need to do the triangular ends because the roof apparently has shingles and they're just talking about the roof or the peak. Okay, so back up. So this part of the triangle is your 30, and then this is the height of 10. So 30 times 10 is 300, and it's a triangle, so we have to divide by 2. So this end is 150, the back end is 150, so we have 300 in the roof. Add those together, and we have 2,400 square feet. Okay, so one side of the rooftop measures about 18 by 40. The top of the entire roof will be covered with shingles. How much area will be needed for the shingles? And then part B, they're talking about the shingles again. There's 48 shingles in a box. Each shingle covers a 9" by 9". Okay, we're talking about feet before. So how many square feet will a box of shingles cover? And how many boxes are they going to need? Okay, so pause and try those, A, B, and C. Okay, so if you're looking at the picture of the roof there, it covers 40 by 18. So multiply that, 40 times 18, and you get 720, and there's 2 of those. Whoops, gotta get my pen. So we got 1440 square feet. Okay. All right, there's 48 shingles in a box, and each shingle covers 9" by 9". How many square feet will one box of shingles cover? Okay, for this one, 9 inches is 3/4 of a foot. So I did turn this into decimal this time. I tell you never to do that, but sometimes it does turn out better that way. So if we take 3/4 of a foot times 3/4 of a foot, let me do this here. We get 0.5625 is our answer. And we have 48 shingles in a box. So I take that times 48, and the answer is 27. So if we need 1440, let me change the color of my pen here again. If we need 1440, take 1440 divided by 27, and it comes out to 53 1/3. So how many boxes do they need? They need 54 boxes. Okay, moving on to number 3. To decide what size of heater to install, the builder needs to know the size of the interior. So we're needing volume now. What is the volume of the interior? So remember, length times width times height. Go ahead and figure that one out. So the bottom part, we had 40 by 30 by 15. Take 40 times 30 times 15, and you get 18,000. And now we need the roof. I looked back at the picture here. You need to take half of this, let me get up. There's your base of your triangle. There's your height of your triangle. So we need 30 times 10 and half of that. So basically if I take 15 by 10, I get 150. Take that times 40. So 150 times 40 is 6,000. So I had 1,800. And if I add the 6,000 for the roof, we have 24,000 cubic feet. So 24,000 cubic feet. Okay. Math boxes are on page 337. And there they are. And study link is here. All right, that's it for lesson 7-9.